As we move into more complicated data structures, we definitely need to have an understanding of Java classes. To some degree, we can take them for granted for a while as a Java programmer, but not terribly long. And eventually, we really need to understand how they're built and how we move from the concepts of UML into actually building individual Java classes. So the important thing to remember that the main function of a class is to act as an object factory. It defines the characteristics by which it's built. It then produces them. It cranks them along. They're used for references. But if you think about, the Model Ts coming off this factory line, the second it leaves the factory, it is self-contained for the most part, and that's what we need to understand about classes. We will write code, and some of that code will be leveraged, but it's not one cohesive thing. I don't run back to the factory every time I need to, add gas to the car, or I choose to drive to a new location. So the idea is to build these little autonomous self pieces inside of there. And it has a big influence in how we need to think about code. No longer is there some sort of magic fairy who lets me just say, hey, I want this thing, and it magically appears. Now I have to be very, very aware in coding with Java. Who am I asking to do work for me? And this idea of a class is exactly it. We get to build exactly the worker we want it to go with. So, excuse me, in a Java class, we have this notion at the top of every file called the public class. And everything that's inside of the curly brackets is part of that class. It becomes what's called a member of the class. And members can be attributes or methods or other classes in some cases as well. So in general, there's only one class per file. But the first thing you have to know is that file must be named. It has to match. Whatever your class name is, that file must match that. Some languages do not have any care what the file name is. It can be anything at all. But in Java, it is super important that when I have some class, it's in a file, some class.java, spelled exactly the same, including capitalization. It is possible to throw another class inside of there. Very, very, very rare. But it cannot have a modifier, which means it's not visible to anybody else but this specific class, or files in the same folder as the other allowance inside of there. So it's really more common that you have a bunch of files, each one containing one class inside of Java. Now, as I said, the members inside of a class generally are attributes, constructors, and methods. Constructors being a special type of method we'll talk about a little bit later. And that relates to the UML that we've saw in a video before, and hopefully you're becoming a little bit familiar with. But the class name is the top bit that we talk about here, and then the attributes show up in this middle bit, and those are going to be attributes in our class. It's going to be a special type of data item we add. We're going to talk about in a second. And then constructors are special types of methods that the name matches the class name, as we'll talk about. And then methods is everything else, all the behaviors that go along inside of the class. So in our big class diagram model, it's important to understand that as we're talking about classes and the relationships between classes, those relationships generally become attributes in Java. So Java attributes and associations are pretty much the same thing. When I link to other classes, you see I have the name of some other class here. So there's no ability to draw lines between classes. It just is saying I have some variable in my class that is keeping track of some other object out there, and I'm going to do that through a class attribute, a variable for that. One other little fact about attributes is in much of Java code, anytime you're dealing with local variables, you have to initialize them. But attributes of classes are given what's called an appropriate zero default value. They're automatically initialized. So if it's an integer, int, short, long, it's going to be a true zero. A character is a null character, which is the 0th character. Floating point is 0.0. Booleans are all false, and any other references to other objects start as null, unless you specify them otherwise. All right, so the important thing we have to understand is that attributes are declared and look like any other variable except for where they are declared in a file. So anything that's inside of the class, like we talked about, the curly brackets inside the class, but outside of any other method is what's called an attribute, which means it doesn't matter what the task is, it's something that's remembered for a long time. So think of it this way. You might have done 100 pieces of homework that you don't remember anything about outside of just cranking through that homework. You did the piece of paper, you followed the instructions, you may or may not remember it ahead of time. Those became local variables. The attributes are the things that sticks with you beyond that. It's what you remember from one homework to the next. Now, I'm a little bit tongue-in-cheek inside of there, but that's the idea of the attributes are the class's memory, not just the information it uses in the moment. Like I did my taxes a few months ago. I don't remember any of the details of those taxes, but I did them and I had that in memory for a while and I really knew the numbers at the time. But right now I couldn't tell you how much I paid in taxes last year, probably even within a few $100s. Um, but what I can tell you is that, I did my taxes. I kept that around. I can tell you what my social security number is. I can tell you, um, what my filing, I can't remember what day I filed, but I can tell you what the filing year was. And so that's the idea of attributes. It's the big important things that we need to keep track of from one task to the next. So as a quick little quiz, not being great in any way, how many attributes are in this class? So pause maybe for a second and take on this question. I'm going to walk you through it here in just a second. But it's important to identify attributes versus other types of variables. So maybe go through and count how many variables from the whole class and then identify which ones are attributes. And then unpause it and I'll give you my count. All right, so hopefully you're unpaused. So let's go through everything that's a variable. We can tell it has a name and a type. So 1, 2, 3, 4, 5, 6, 7. So there's 7 variables inside of here. So which one of these variables are actually going to be attributes versus which ones are going to be classes? So a local variable, I'm going to identify those in orange here. A local variable is anything that's inside of the curly brackets here. So inside the curly brackets, so there's one local variable. And also the parameter here counts as a local variable. So those are all local variables. So basically anything that's not inside one of the methods becomes eligible for being one of the attributes. So these two up here are constant attributes. So these are attributes right here. They just happen to be constant because I made them final. And then these 3 down here are also attributes. It doesn't matter where in the file they show up, top, bottom, anywhere in the middle, they become attributes because they're outside of a method, which is why in general, the rule is you either put all your attributes at the top or the bottom of the file. In this case, I can make the exception because the constants are public and up top and you want people to see them and everything else is hidden down the bottom. But style says you should keep them all together and it's important to adhere to style to some degree. So that way we have a good feel for where things are and we don't get confused about why is this extra attribute? Where is this coming from as we're reading the code?